so that because some of the centers are dropping out some of the time, so I will record this and we will see if we can name this. So there it is. Oh, I think Genesis have already done it. Yes, very good, very fast. Genesis are in front today. Tumaini, you must catch Genesis. They are going very, very, very fast. Silver Spring, you will catch up, I promise, but they are cheating because they have seen me before. They already know something. We have a guest professor in Genesis at the back. We have teacher Sophia. She is a well-known professor of chemistry, and she will be taking the lesson from now. Okay. Whoa, we have an answer already. Wait, sorry, I have to make my screen bigger because it's difficult to see. Whoops, hello, where's it gone? Ah, come on. Hang on, just hold it there, just pin. Ah, now really nearly, there's one little bit missing there. There's one tiny little bit missing, Fatma. There's no naming of the BRs. The BRs are missing. That's so close, so close. Oh, we've got somebody else. Is that Michael, I think? Hang on, let me just have a look at it. Sorry, I have to pin it because it's difficult to. So Marlene. Oh yes, it is, but that's not quite enough, Marlene. Not quite, because there's more than one of them. There is more than one of those. Oh, really close. Not quite. It's not een. To have een, it would have to have a double bond. A double bond. I'll tell you what people have said so far. If you just watch for a minute. What people have said so far is we have had bromo, which is correct. And we have had pent, which is correct, but it's not everything, because this is no double bond, no triple bond, so it's ane, okay? Oh, hang on, we've got another one. Whose that? Michael, let me have a look. Ah, close, not quite. Oh, and another one. Fatma has somebody, hang on. Let me just pin her so I can see it. Let me see. Oh, really close, really close. Let's just have a look at it. Okay, here we go. Look, let me just show you one thing, everybody. Look. Oh, there's one there. This is, you look at it and you say, if I take the BRs away, it would be pentane. But there are bromos. How many bromos? Ah, there are 3. So 3, this would be bromopentane, that would be bromopentane. But there's not 1, not 2, but 3. So we call it tri. Like a tricycle, 3 wheels, tri-bromo, yeah? Okay, everybody okay with that? So tri means 3 of them, so that's sensible. And then we say where they are. So I count, so I'm going to count from this end or this end, doesn't make any difference. 1, 2, 3, 4, 5. So they are on 2, 3, 4. 2, 3, 4, tribromopentane. Try to remember this. Try to remember that. Because if there is just 1, then we just say bromo. If there are 2, we say di, di. And if there are 3, it is tri, okay? We hardly ever come across tetra, okay? So it is 2 equals di, 3 equals tri, and 4 is tetra. Okay? All right. So that's quite a good thing to remember, but you were so close, really so close. Very good. Okay. So now we're going to go and we're going to look at some questions. They're all from KCSE, so they're all simple, not simple, straightforward, but they are proper questions which you need to know. So I'm going to just share my screen. Here we are. I want to go to number 9. Whoops, here. Okay, this is a very common question, a very common type of question. Oops, sorry, wrong question. Oh, sorry, just a moment. Okay, here it is. So it is asking for the names of these compounds. Now, if you look at these, what you have to do is just what we have been doing now. This one here, I think you can name the second one very straightforward. Just have a look at this second one here. Okay? So this second one here has this. This triple bond means it's an alkyne, doesn't it? Alkyne, okay? So CH3, CH2, CH2, C, etc. And then this. And this one, and I will draw them on the board and we will have a look at them. We are only going to do these two. This is a proper KCSE question. This was worth 4 marks, which is amazing. If you can get 4 marks for this, that's brilliant. So let's have a look at them. So here we are. I'll just get rid of this. Try to remember these. Okay. CH3, CH2, CH2, CH. This was the first one. Sometimes it is easier to draw it out in what they call open structure, okay? So I often find it's better when I draw it out. To draw it out, you have to remember that every carbon has 4 bonds. I start here, so I pick this carbon. And then I just show 3 hydrogens, 1, 2, 3. Next carbon, 2 hydrogens. Next carbon, 2 hydrogens. Next carbon, triple bond. Next carbon, hydrogen, there. So that is the molecule. Proper KCSE question. Okay, so we look at this, and the first thing you should notice is this. And you just say, I know that. What is that? Yes. And then, so we're going to call this an alkyne. This makes it alkyne. So its name is going to end, I'll just move the first one. Its end will be -ine. It's right at the end. There are 1, 2, 3, 4, 5. That makes it pent. And it's on the first carbon. They almost always on the first carbon. Pent 1-ine. Okay? If you got that, fantastic. Okay? Pent 1-ine. There it is. The second molecule, I will show you. Let me just check it myself. Yeah, okay. The second molecule looks like this. This is the last one we are going to name. Then we are going to do some proper chemistry. The other one was like this. CH2, CBr, CH3. So we draw it out first. Quite often they ask you to draw the open structure, open showing all the bonds. So I start here, first carbon, 2 hydrogens, 1, 2. Then double bond, carbon, with Br here, and then single bond, CH3. There, this is it. So, what do we see? Well, I see this. This is the most important part. You should probably know that that makes it an alkene. Okay, so this is an alkene, but it also has this on it. This is quite a hard question. So I'm going to name it for you so we can get on a little bit. If you want to just think while I talk, that's fine. You try and work it out yourself, but I'll show you how it works. So what I do is I go, this Br is almost always not very important. So we treat it poorly. We say, you're not important. This here is very important. This makes it an alkene. Alkene always ene. Okay, always ends. I'll push it a bit further over. Always ends ene. It has got 3 carbons. Long chain, just 3 carbons. So 3 carbons makes it prop. And it has this extra on it. So if that was a hydrogen, this would be propene, but it has Br, which makes it bromo. So it's bromopropene. We don't really need to say where the double bond is because it could be here or here. It doesn't make any difference. It's still on the first carbon. But the bromine, we need to say where it is. It is on 1, 2, 3. It is on 2 bromopropene. Okay? If you said prop-1ene, that's fine. Not necessary, but that's it. Okay. So you can do that. So hopefully you are feeling a little bit more positive about naming. Don't worry, because every time we have a lesson, we will do shorter and shorter naming because it is so important, okay? Just a little bit sometimes, okay? So now I want to show you this question. Here we are. Whoops. Let me just get to the proper slide. Right, this is it. So this is the question we want to have a look at. Okay. What I want to do is to have a look at this question and see if we can work out what these chemicals are. Okay. So we're looking at this question and trying to identify what these chemicals could be. So if you look at it, you'll notice that all of them have just 2 carbons. 1, 2, up here, just 2. Down here, just 2. These 2 we don't know. So they are F something, F, okay? This makes it F-ine, so ethine, okay? This is ethine. This is ethane. If I draw it out, I will find there are no double bonds, all single bonds. That makes it ethane. This down here has got bromines everywhere. Bromines on both carbons, 2 on each one. This here with oxygen in excess, that turns into water and something else. And here HCl turns this into something else. So what we're going to do is we're going to have a look at this chemical, this bunch of chemicals, okay? So here we go. Let me just bring this down. Okay. So I'm going to just show you this in a slightly different way so that you can understand it in a slightly different way. So here we go. These are the molecules here. This one is the one in the middle. Carbon is shown as black and hydrogen as white. And you will see that the carbons are linked by 3 bonds in the middle. 1, 2, 3. So this is ethyne. Now, one of the funny things about organic chemistry is realizing that a single bond makes something strong, but a double or triple bond makes it weak. Not weak to cut right through it. If I was going to cut straight through, not weak there, but this bond and that bond, 2 of the bonds are weak. This one is ethyne. And in the question, this one is turned into this one. This one here, if you look at it, 2 carbons, and each carbon has 3 hydrogens. So this is C2H6. C2H6 makes it ethane. Now, when you look at these and you say, okay, how do I turn this into this? It's obvious. I just count. I have 2 carbons. This has 2 hydrogens. This one, this has 6. So I have to add hydrogen to make this one into this one. And it works really easily. If I look at this one to this one is still 2 carbons, 2 hydrogens. This one, 2 carbons, 2 hydrogens, and 4 bromines. These green are meant to show bromine. So to make this one with the triple bond into this one here, I have to break the triple bond and I add 1, 2, 3, 4 bromines. So let's have a look at the question again. So some of the time, the best thing you can do is to look at, the question. Sorry, I'll just move you across. Here we are. Is to look at the question and just count. So I look at this and I go 1 carbon, 2 carbons, 2 hydrogens up here, 2 carbons, 6 hydrogens. So step 1 must be adding hydrogen. In step 2, if I look at step 2, this 1, 2 carbons, 2 hydrogens, this 2 carbons, 2 hydrogens, and 1, 2, 3, 4 bromines. And you probably know that bromine goes around in pairs. It is Br2 normally. So if it is Br2, then step 2 will be with 2 Br2s. Now this one here, going across here, to make water and B, in oxygen, excess oxygen, I think this is burning. And when we burn something, what happens is that we get something very different happening, which is we get a destruction of the molecule. So we get water and carbon dioxide. This one up here, we will just look at with HCl. Okay. So back to this picture over here. I have now this, and if I start to add HCl to it, so I'm going to say these are HCl. If I add these here to this, what happens is this. The double bonds must break. The 2 of the bonds must break. Then these ones must join on. And what must happen is that we get this happening. So instead of the triple bond, there 1 hydrogen has gone on 1 chlorine on the other, and this one will break as well. And what we get is a new molecule where it doesn't have the double bond anymore. And now each of the carbons has hydrogens, 2 hydrogens each, and the chlorines. So we'll look at that on the other camera. So I'll just do that on the board. So let's look at it. Okay, so the question is, if I start with this in the middle, how do I make this? How do I make this? What happens when I make water and B with oxygen going that way? And what happens if I add HCl going this way? This is what the question is asking. So if you want to scribble down the question, it's a good idea. This is quite a hard question. I'll show you what it asks. Okay. So you look at the first molecule here. Count the number of carbons, number of hydrogens. Okay, I've got 2 carbons, 2 hydrogens. I need to make it into this. I count 2 carbons, 6 hydrogens. So to make this into that, I would need to add hydrogen, but I would need 2 of these. I would need to add 2 of these because 2 carbons, 2 carbons, 2 hydrogens, 6 hydrogens. I need to add 4 hydrogens. Coming down this way, 2 carbons, 2 hydrogens here, 2 carbons, 2 hydrogens, and 1, 2, 3, 4 bromine. Because bromine goes in pairs, it is going to be Br2. 1, 2, 3, 4. I need 2 Br2. Okay? So that would let me write an equation if I needed to, if I was asked the question. This one here, if it says excess oxygen, they are assuming that it is burning completely. So if you get water, the only other atoms I have here are carbon, and therefore carbon B must be CO2, must be carbon dioxide. If it's excess oxygen, it forms carbon dioxide. If there isn't enough oxygen, you know probably it's very dangerous, forms carbon monoxide. Okay, so if I add HCl to this, what will it make? Well, my molecule here, which I did, suggests that 1 hydrogen and 1 chlorine goes on each one. So in other words, the triple bond breaks. I have my original hydrogens like this, and then I have HCl, HCl, HCl. That's it. That's all. Every time you react with alkene or alkyne, whatever attaches, it breaks into Br2, BrBr, HCl, HCl. Okay, so that's the question. All right, let's have a look at it. So here is the question. Where's it gone? Here's the question. All right, so that's the structure which I had on the board, and these are the questions. Whoops, sorry. So the first question was, to which group of hydrocarbons does substance in one above belong? So in other words, what is that? And if you can do your naming, you know that question 1 says, to which group of hydrocarbons, you can go, I know, that is alkyne. In part 3, this says give the name of the substance, that's ethyne. In part 3, give 2 reagents that can be used to prepare the substance named. Now, you may not know how to make ethyne. Ethyne is made from calcium carbide and water. So this chemical they quite often ask this question. It is calcium carbide and water makes ethyne, okay? You don't have to write the equation, it's just that is it, calcium carbide and ethyne. They just ask the question quite often, how do you make it? They don't ask you anything clever, just how do you make it? Okay, so back to the question, here it is. All right, the next question. State two physical properties of this and give the names to the process in 1 and 2. So, whoops, one process, step 1 and step 2, okay? So this is naming this and some physical properties of ethyne. Okay, let's see, does anybody know? Alkanes, alkenes, alkynes all have the same sort of properties. Can anybody tell me what sort of properties they have? Can anybody tell me? The properties of alkanes, alkenes, alkynes, all the same properties. Anybody tell me? They are all very simple molecules. They are not complicated and they have almost a very, very small intermolecular forces. So the physical properties, I will tell you, if not sure, anybody want to have a go? Anybody out there want to have a go? Okay, I will tell you. It's important. This is very important. Simple chemistry. Alkanes, alkenes, alkynes, all low boiling point. That means that they are normally a gas. This ethane, a gas. Ethyne, the triple bonded, a gas. And they do not dissolve in water. These are the two best physical properties. They have low boiling point and they do not dissolve in water. And they are both for the same reason. You probably know hydrogen attached to oxygen in water is polar. That means it's a little bit positive, a little bit negative. Because it's a little bit positive, a little bit negative, it attracts another water. So one water molecule attracts another one. This ethane is not polar. So water and this, they're not attracted. So this can't dissolve in water, can't happen, okay? No dissolving at all. And because this is not polar, it is not attracted to other things which are not polar. So if I had another molecule, they're not attracted, so they disappear really quickly. They evaporate easily. So low boiling point, okay? All right, so this is the best two physical properties. Only learn two. You may be taught lots, just learn two. They never ask for more than two. The next question was about process 1 and process 2. Process 1 was, okay, everybody got that, I hope? Low boiling point and do not dissolve in water, because I don't think you'll be asked, but water is polar and these are not polar or non-polar. They are not charged at all, no charge, so not attracted, okay? So, just get rid of this. So the first, it asked you about the name of the processes, and it was from this to this. And from this, so they were asking about this one, and about this one. And it asks for the name of the process. Whoops. It's a really simple rule. This is adding hydrogen. So this is hydrogen, and this is bromine. Okay, these are the things which are added, and this is called hydrogenation. Hydrogenation, sorry, okay? And this is called bromination. It's like oxidation and reduction. They're just names, they're easy. So hydrogenation is the addition of hydrogen. Bromination is the addition of bromine, okay? In this case, 2 bromines, 2 hydrogens. Doesn't matter how many, adding hydrogen, hydrogenation. Adding bromine, bromination. Okay, and the last bit of the question before I show you one thing, I show you one last thing. Here, it says, write an equation how substance A is formed. So in the question, substance A is here, and this is what we start with, and we add HCl. So let's have a look at that. So this is the last thing we're going to do. So we're starting with this and HCl. So it's different from these. This is the one that was up here. Your supervisors have the print of this so that they can show you it later. So it was about the one that goes up here with HCl. So we write this out as C2H2 plus HCl. Now, because it's triple bonded, this can break one time, add HCl, and another one, HCl, okay? So each extra bond, so we always keep one bond, but if we have 3, we can react with 2 HCl's. So this is going to go to this, okay? But it's going to need 2 of those. So now I have here, this here, I write it out, CH3, next carbon, CHCl2. If it had gone the other way round, so if I start again, so I have C triple bond like this, and I break 1, and I get HCl, and I break another one, and it goes the other way around, so it goes Cl here and H there. This is also correct. Both are okay. So this would be written, not like this, but C, 1, 2 hydrogens, and a Cl on this carbon, 2 hydrogens, 1 Cl, and then the next carbon, 1, 2 hydrogens, and Cl. It's okay if it's H2Cl or ClH2, doesn't make any difference. Now, where it might go wrong, okay, so both of these are okay. This is okay, this is okay. Both okay. Both. Hey. All right. So these are both okay. Where people get this wrong is this. They write this. What you have to do when you check an equation is to write down everything both sides. Make sure you have the same number each side. Let me show you very quickly. Okay. Here in the middle, I write all the elements. So I go CHCl. That's all the elements I have. So if I have not balanced, this is not balanced. I'm sure you can get balance, but sometimes it's more complicated. So let's have a look. I count all the carbons on this side. 2. Hydrogens on this side. 1, 2, 3. Chlorines. 1. On this side, 1, 2. Oh, that's good. 1, 2, 3, 4. Oh, Oh, okay. Chlorines too. Look, this is wrong. So this shows me I need more. So I say, okay, Cls, I need more here. Okay. I go 2, and that will make 2 there, and hydrogens now 1, 2, 3, 4. Okay, good. That's it. So that's why it's 2 HCl. Okay? All right. So I thought I would show you something quiet and gentle after this lesson, just a little bit of practical chemistry. I just thought it might be interesting to see a chemical reaction. I just have to put my lab coat on. Because the chemicals are not very nice. The chemicals are quite hazardous. Okay. This is a peculiar reaction. It doesn't make a big bang. If you saw the one last time, it makes a big bang. This one is very gentle, but it's peculiar. You are probably wearing cotton. Cotton is a polymer, and we will do some questions about polymers. What I'm going to do here, I'm going to show you how they make nylon. I'm not going to make a long string piece of nylon, but nylon is used for football shorts and many other things, okay? So I'm going to turn on the other camera and we will see what I'm talking about. So here we go. Okay. I have here 2 beakers, 2 small glass jars. Oh, can you stand up, please? Oh, it doesn't want to stand up. Okay. So I have 2 small beakers here. And what I'm going to do is they have cling film on the top because they give off nasty fumes, bad fumes. So I'm going to take the top off, these, like this. And I'm going to pour this one on top of this one. And they don't mix properly. What they have done is they have formed 2 layers. I don't know if you can see that, but it is 2 layers, one on top of the other. Now what I'm going to try to do is to see what's happening on it. And where the chemicals mix, they make a new chemical. And this new chemical is nylon. And I can pull it out where the 2 layers touch each other. It is not easy to hold. Where the 2 layers touch each other, it produces a solid. And you can see I am producing a solid. I'm just pulling a solid out of 2 liquids. That is quite peculiar. This is how they make nylon. It is just where the 2 liquids mix, they make a solid. So they don't mix properly. And I can make this really, 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 really long. And this piece of string here is not very strong. But when they make it in industry, they make it very carefully. There is some industry down in Mombasa which makes nylon. But what is peculiar is that it is just forming where the 2 liquids mix. So they can't mix properly, but where they touch, there forms this solid. And it just keeps on going. Now, if I mix the 2 liquids, eventually I make them react. And this is used for bearings, for making washers and so on in machinery. Not clothing, but this is a very frictionless solid, nylon is. So what it does is it is possible to stop friction between moving parts. So it's put where we want to stop things rubbing against each other. So the two liquids, they don't mix. It's like oil and water, but where they touch, they react, and then you can get that out. Okay. Next time we will answer some more questions, but next time, and your supervisors already have them, they are questions from the middle of the PowerPoint, and it's about fractional distillation and cracking. And we will do that, and then we will do something completely different the next week. Next week, I will try to explode something or show you something a little bit crazy, okay? But until then, I say goodbye, and thank you very much for being here. And really, honestly, students, you are great. To come in at the end of school and to do this is really excellent. So well done. Seriously, well done, guys. Very, very good indeed. Thank you very much. And goodbye. Bye. You can go now. Be free. Oh, I forgot to ask Sophia questions. Bye, Fatma. Bye, Michael. Bye, guys.
Bye, Dan. Bye, Fatma.
Yeah, think Kwaheri.
Kwaheri.
Yeah.
I now have to go back to more work.
Yes, you deserve it.
Thank you so much.
Cheers, Mark. Thank you.
I hope that was a bit more the right level for the students.
They were all looking very focused.
They were, yeah. So let's hope. Yeah.
Yeah.
All right, mate.
I think it's going to chip away bit by bit. I think it's going to work bit by bit.
Bit by bit is the business.